I'm going to start the rebuild by reinstalling the brush holders into the motor casting. Next is the field, and I'm going to mount the field, and I'm going to fish these switch wires through that hole right there, which goes into the switch cavity through the handle. And I'm going to line the mounting holes to those two bosses above the brushes. So here's the newly degreased field. Wires feeding through. Okay, as you feed in the field, got to make sure the switch wires go up the handle cavity to the switch. So as you feed it in, you kind of got to turn it back and forth, and then just take a chopstick and gently guide those wires up the handle cavity, like I'm doing here. Just give them a start. You'll be able to see those, but you can see the wires in there. I kind of guided them up the handle cavity, so now as I push the field the rest of the way, and they'll just go up there on their own. So in go the field mounting screws. Okay, a word about running screws into these old die castings. If something ain't running free, don't force it. If it's binding up, take it apart, put it back together again. This old aluminum will strip out, and this is a steel screw into an old die casting. So if everything isn't running free, just take it apart, make sure it's free, and start over again. Okay, next step is getting the brush conductors onto the brush holders. So it's those little spring things right there have to get on the brush holders. So you're gonna need some special tools for this. A broken chopstick, a long skinny screwdriver, and a nice teaspoon. So what I do is I spear the brush holder and align the brush conductor with the brush holder. Then I take the ice teaspoon, the handle of it, and I pinch the bottom of that spring right against the brush conductor. And I take the long screwdriver and use the spoon as a fulcrum, and she snaps right on. So now you can see it's happily mounted right there. Hope that comes out in the video. Right there. I'm gonna do the same thing on the other side. Okay, there you have it. They're landed, both of them. Now the next step is just take a chopstick and dress the wires in there and make sure they're out of the way of the bearings and not gonna brush against the commutators or hit the rotor. Oops, broke a chopstick. Lucky thing I have a spare. Okay, there's the switch wires up into the switch cavity. Field is all screwed in. Brush connectors are connected. Wires are all dressed in. Next step is installing the rotor bearing on the little end of the rotor. I'm going to put the shield end towards the rotor, and it's a very light press fit. Didn't even need any effort at all. Next is the big rotor bearing, and it goes into the diaphragm that fits on the front of the motor housing. So I decided to replace it. I bought an NTN equivalent, and it just goes into this little steel sleeve that's pressed into the diaphragm. And then since it's got these two features on the back, I just bridge it with a little plywood scrap, and then enlist the Garland #1 persuader and just tap it in. Again, Garland #1, just a few love taps. A word about orientation. So here's the little shaft that holds the rear bearing of the intermediate gear shaft. So that goes up, because on the inside of the gearbox housing you can see the needle bearing, which is the other end of the intermediate shaft, is oriented in the up position. It goes like that. So I'm just going to borrow a couple of the handle screws just for a moment, just to align this so I don't lose the alignment, and then just tap it home. Okay, now's a good time to check brush clearance. First, make sure the motor spins freely. I'm spinning the input shaft with my fingers, and you can see the commutator spinning around in there. See it? Okay, so I'm going to take another special tool, which is a bent baggy tie, and I'm going to stick it down the hole for the brush holder. I'm going to make sure that I can get between the commutators and the brush holder, but I can get it in there, so brush clearance is good, which means I can snug up the set screw. Okay, done. Just snug. Nothing on these old tools needs to be super tight and reefed down. Just snug is good enough. Okay, as a last check, make sure the brush holders are aligned so that the square part of them is aligned to the commutators. I'm going to go the brushes, like so, and the brush caps. I'm putting these in now too, because I want to test this thing before we go any further. So, other side. Just snug. Okay. Motor assembly all good to go. At this point of any build, I like to test things electrically to make sure that nothing's been missed. All the basics are in place before I start burying it deeper and deeper in the assembly. So I screwed the diaphragm down so that the motor is in position. We just installed the brushes. Motor spins freely, even with the brushes in it. I got 2 test leads hooked up to a power cord, positive and neutral, and I got them plugged into a plug strip down here, so watch the motor output shaft, and I'm going to turn it on. I got her good and clamped down too. Working like a charm. So I'm going to reverse polarity. You don't really have to do this, but again, my obsessive personality, I can't not do it. And you notice the motor turned the same way. So, which it was going to do anyway. It's just how an AC motor works. We are good electrically. Okay, so we just tested the motor. Everything's turning, nothing's burning, nothing's hitting anything else, didn't smell anything. Working good. So, little needle bearing that I decided to replace. The replacement didn't show up today in my McMaster shipment, so I have to wait till tomorrow. And then once I get that, we'll be able to reassemble the gearbox, reassemble the Scotch yoke and the ram, get it attached to the motor housing, and cut some sheet metal. Despite what I said in the teardown video, I went ahead and removed the eccentric shaft from its main gear so we could replace this bearing. And we wanted to replace this bearing because this one is open. You can see light coming through it. And it is the only thing that goes between the Scotch yoke passage and the gearbox. So I wanted to put a seal in here to keep the liquid oil that goes in the Scotch yoke passage from the packing grease that goes in the gearbox, because that was one of the reasons this thing was getting so gooped up. So I just knocked that gear off of that shaft using that drift, which is a relatively new Dasco made in USA, and this ancient 2.5 pound plumb ball peen hammer and a couple of good whacks. And I did it on top of this snap-on 1/2-inch drive socket. May Joe Keegan forgive me. And we're going to replace this bearing with this bearing, which is sealed. So I'm going to give it the light test. There's no light coming through it, so it'll keep oil and grease apart. Also came today is the 1/2-inch needle bearing that goes on the small snoot of the intermediate shaft. So now we got all our parts and we can reassemble the gearbox. Using the old bearing as a little stand, I'm going to put the eccentric shaft in there. I'm going to drop the new bearing, which is just a finger tight fit, onto the eccentric, and then I'm going to put the gear back in place. You know, it's got two sides to it, so this little hub feature faces up. The back is almost smooth, that faces down, but this doesn't want to cooperate. So we're going to give it a little bit of, we're going to help convince it with a little bit of this. So just going to warm it up a little bit before I tap it on there. Garland number 1, rawhide end. There you have it. Brand new sealed bearing. On to the next step. The bearing for the nose of the eccentric shaft, this one lives way down in there, and it's going to live a life in oil, but I'm going to give it a little bit of packing grease on the back side. Just to make its life a little more lubed up. Don't need a lot, just get it in there. Okay, to install it, I'm just going to push it up through the yoke hole. Align it in its pocket, which is right there. A word about tapping in bearings. When you're installing a bearing and you're using a socket or something else to tap it in, try and get the best fit you can on the outer race. That's really where you want to apply the load, or on the inner race if you're popping it on a shaft. The point is, don't use something that's too small in diameter and end up popping on the shield or the cage, or hammering on the shield or the cage. You'll just ruin the bearing. So this little socket fits pretty good on the OD on the outside of the outer race. So I'm just going to use it, and hardly takes nothing at all, and it's in there. Okay, the little needle bearing goes in there. This thing's gonna fight me, so I'm gonna use the wife's hair dryer and warm this pocket up, expand that aluminum a little bit. The advantage to using the hair dryer is it doesn't get it so hot that you can't handle it. I could have used the MAP gas torch, just putting a little grease on here, but that gets it too hot to handle. So warmed up, lubed up, a junk socket that fits basically on the outside race. She's home. Okay, this thing lives in packing grease, so I'll directly lubricate it with the lithium grease here. I'm just using this stuff. Okay, it's time to start assembling the yoke. First thing I'm going to do is lube it up with the lithium grease and the broken coffee stirrer. Like I said, it lives in oil, so it's got a pretty good life, but a little lube never hurt. Okay, now direction's important. So here's the shoe. Now it cuts this way towards me, and you can see the upper bit screw and the upper bit adjuster right there. So the yoke goes into the shoe such that you can get to the screw and the adjuster. So we're cutting this way. So that then fits up into that oblong hole such that the front is facing me. Just like this. So pretty simple, just slide it up there. A little love tap with the garland. All right, rest of the Scotch yoke. So now the block that we talked about earlier. A little bit of grease from the dirty coffee stirrer, dirty broken coffee stirrer. Inside and out. Again, not a lot, but enough to get her lubed up. Now, as we said before, this needs to move side to side freely, but be restricted by the yoke up and down. So it goes in long legs up and down, short legs side to side. Drops in like so. Eccentric. Same deal. A little bit of lube. lube on the bearing just to make it insert a little bit easier. Lube on the eccentric. And lube on the gear. We'll grease it up really good later on, but right now just enough to get things to slide together. Okay, and that eccentric goes into the aperture on that bronze block and picks up the bearing inside on the far side of the Scotch yoke passage. And there's that. So now I can turn that gear and you can see the shank going up and down, just like she's cutting sheet metal. Okay, next step, intermediate shaft. Same deal, not a lot. And then that very simply pushes in here, like so. Okay, the rear gear for the intermediate shaft goes in there and it rides on this trunnion. So we're going to press it on here first, since that's not a press fit and this is. So just get her started. And then a couple of love taps with the garland. Okay. Now it's time to pack this baby up with grease. Okay, I'm just using a carry-out fork that I snipped the tines off of because I couldn't find a carry-out spoon. Good and loaded up. Okay, then typically I like to spin the gear train. Make sure you're getting grease all the way around the bearings, all the way around the gears. Everything's meshing. All right, now time to put the motor housing and the gear housing together. So you gotta line three things at the same time. You gotta line this bearing to the rear pocket on the intermediate shaft. This little dowel hole to that little dowel right there. And then the motor output shaft to the outer circumference of the intermediate gear, the rear intermediate gear. So I'm going to start by rocking it in. To get the bearing seated first, the dowel seated second, and the gear seated third. And you can see the diaphragm is aligned. So finger start a couple of cutting bits. Lower has the rounded end on it and a straight cutting edge. The upper has a square end and a beveled cutting edge. So let's do the upper first, since we're right here. It just drops onto the shank. A little 1032 socket head screw. And I'm going to run it right up against the blade adjustment screw, which is right there. The lower bit has this little nut, little flat-sided nut that drops into the slot on the lower bit, like so. Then it goes into a little pocket on the shoe. And then a little 1032 Allen screw threads into the nut. All right, I'm going to take a little screwdriver and I'm going to force the lower bit all the way out. Then I'm going to take the lower bit adjusting screw, which is this little socket head set screw, and I'm going to thread it down until it hits that lower bit. Right about there. Okay. Now I'm going to snug down, make sure that's up against the grub screw or the set screw. And I'm going to snug down the lower bit, not super tight, just snug it down. And then I'm going to take a piece of cardstock. I'm going to stick it in between the lower and the upper cutter. And I'm going to adjust it so it just is catching right there. Right there. And then I'm going to hold it at that spacing with the little screwdriver and snug up the lower bit. Okay. All adjusted. Okay, I wired the motor leads to the switch in their original positions. Now it's time to hook up the cord. Black goes up here, so it's got to be the longest. So I'll start with that. Take my old snap-on wire strippers. Just strip off a wee bit. Maybe a wee bit more than that. Ring terminal. Line that good and tight. Make a good crimp. Okay, I'm not going to put any heat shrink on the positive because it has to come out of the top of the switch and then bend down right away. So I got to land that in there. And there's not a lot of room for heat shrink. Just snug on these old switches. These are made of Bakelite. They're very brittle. They'll last forever, but they are a little bit brittle, so easy does it on the torque. Okay, so in position it goes roughly there. So the white goes there. So we'll pull this in a little bit. And maybe whack a ½ inch off of the white, maybe a little bit more. And again, we're not relying on heat shrink because we have to make a very dramatic turn to get the wire going down the handle cavity. And we're relying on the paper for the insulation. Ring terminal. Get a good crimp. Wrap it back up with the paper. Slide it into position. Let's take a look at this ground lead. It looks like it wants to be about yay long. Ground screw goes in that little boss right there. Okay, to install the switch into its mounting position, first thing, lock it using the little trigger lock, and then get the holes aligned, the mounting holes aligned to the bolt bosses or the screw bosses in the handle, and just run them in. Don't tighten them up. Okay, once that's done, then release the trigger and let it force the switch into its natural position, and then tighten them up. Otherwise, you can end up with a switch that you either can't turn on or worse, can't turn off, because it'll be mechanically locked up against the housing. There you go. All right, I'm gonna fire it up. I'm getting anxious. So there's the bits. Let's see here. Power's on, she's plugged in. Oop. Now the power's on. Oh yeah. Now we can put on the handle cover. Little lock washers. And little Philister head screws. Okay, strain relief. Okay, I forced the strain relief flange inside the handle cavity with a chopstick. Now I'm going to attach the little saddle. I added a couple of AN washers on there, just because. Let's get this finger started, like so. Okay, lubrication. I'm going to use Hoppy's number 9, nice light oil for now. I searched around on the web and I couldn't find any references for what oil to use, but I do know it's got to drain down a very narrow passage in here, so it has to be a pretty light oil. And Hoppy's has never let me down. So I'm just letting it drain. The oil cap. Okay. Final thing, the nameplate. Don't that look beautiful? Okay, let's see how she cuts. Her piece of 16 gauge. So there she is, all done and ready for service. Good for another 50 years. So I'm gonna leave this one here. We're gonna pick out another tool to be rebuilt, and I'll see you then.